Hello. In this short video clip we'll be developing the equations that represent a mass on an inclined slope. And I'm going to have friction in this just to make it slightly more complicated. So here I'll just draw the picture, and here we have an inclined slope. This is the not very good there. Try and make it start again. So this is our slope, this is the horizontal, and we'll put an angle here of theta, and on here I will have a block is not resting, but it is sliding, accelerating down the inclined plane. So I'll write that, inclined plane. Now it has friction, so there you go. Imagine it's sliding, it's accelerating in fact in that direction down the slope, and it has a friction. I'm going to have this a constant friction, and we're going to call that friction Fr for friction. So that's one force acting on it. What's the other force acting on it? Well, it's basically the other force acting on it is its weight. So another force acting on its weight, and what we'll do is I will draw this down. I'm going to draw it through the diagram. It'll help later with the geometry of it. So this is its weight, and let's say it is a mass m. So there we go. It's a mass m, and gravity is g. So the weight, in fact, the force acting down from there is mg. Now, of course, it will there'll be a reaction force that acts normal to the surface, and therefore we'll have a reaction force acting there as R. Now, there's no other forces acting on there. We have friction, the reaction force, and the weight acting down. So now we're going to look at this, apply Newton's second law. The resultant force equals mass times acceleration, so I'll put that F equals ma. And apply that. Now first of all, let's look what's happening perpendicular to the plane. So I'm going to extend this line there. Now what's happened perpendicular plane? Now the block's accelerating down the plane, and at 90 degrees to it there is no acceleration. This is not influenced at all, so because vectors are 90 degrees to each other are independent. So what we'll have here, we'll have the this mg and r. How do we relate that to each other? So we're going to resolve. So first of all, we're going to resolve perpendicular, and that perpendicular is often represented by that perpendicular to slope, at 90 degrees to the slope. And so let's have a look. If that angle there is theta, I can do the put in there, that's 90 degrees. Therefore that's 90 minus theta, that's also 90 degrees, so this angle here must be theta. So we'll resolve the along there, so mg times cos of theta. So equation 1, mg cos theta. Now there's no acceleration, so they're just balanced. They balance, the magnitude of the force is the same. Mg cos theta must be balanced to r. So that's equation number 1. Mg cos theta equals r. Now equation 2 involves the application of Newton's second law because there's an acceleration. Now the resultant force equals mass times acceleration. Now we have obviously a friction adding that way, but the resultant force is the component of mg acting down there. Now if that's mg cos theta, this here will be mg, because it's 90 degrees, sine theta in the other direction. So the second equation will be mg sine theta in that direction, that component, minus fr. So we have mg sine of theta minus friction is equal to mass times acceleration. I'm running out of space, so I'll rub that off and writing it. So this time we're going to resolve along the slope, and we're going to apply F equals ma. So we will have from this equation number 2, it will be mg sine theta minus friction must be equal to the mass of the block m times the acceleration. So that's equation number 1. And this here is equation number 2. And depending upon the questions they ask you, you just apply them.